graph of a rational function now. So the function is right here, f of x equals, and we can all see that, and we're going to go ahead and graph it on this axis I have set up down here. Now, before we go ahead and do any factoring, we're going to take a look at a couple things we can get from the function written the way it is right now. For example, we know that if we look at the highest degree term divided by the highest degree term, in this case x squared divided by x cubed, we know that this will tell us whether it's a horizontal asymptote or not. In this case, we see that the degree in the numerator is less than the degree in the denominator. That means that there is a horizontal asymptote at y equals 0. And that takes care of one piece of this function. The other thing that we can get from this is we can find the y-intercept. We substitute in 0 for x. It's fairly quick because I get a couple of zeros, negative 12, and a 0 with a negative 8, and that's a 1.5. So we have a y-intercept of 0, 1.5. Now, the other two items that we're going to need to get are going to have to come from the factored form. So we're going to come back to the original equation, get rid of this extra little clutter, and see if we can do a little bit of factoring. The numerator does factor pretty easily. We know the factoring up here. This is x looks like minus 6 and x plus 2. That gets us our negative 12 and our minus 4x. The denominator, we could factor this, or we could recognize that x cubed minus 8 really just has one real solution that we're looking for and just go with that. I'm going to remind us of the factors. That's just a difference of cubes up here. That's an a cubed minus b cubed factoring pattern, which we have seen, and that would get us an x minus 2, and then we square the first, we square the last, and we opposite the product, so that would become a positive 2x. And one of the things that we've talked about, I know I've mentioned, is that when you do this, this second one has no real solutions. That says has no real solutions if you can't read it, but that's what it says. So the only thing we're going to really worry about down here is the x minus 2. And here's what we get out of this. We get the fact that the denominator x minus 2 means that x cannot equal 2, but that's where we're going to get a vertical asymptote. And the numerator gets us our x-intercepts. And our x-intercepts look like they come at x equals 6 and x equals negative 2. And just like we saw with polynomials, and this is one of the carryovers from polynomials, whatever the behavior multiplicities of those x-intercepts would have been as a polynomial, they are the same behaviors in the world of rational functions. In this case, both of those powers are 1s. Therefore, both of these x-intercepts are going to act linear, because both of them come from a multiplicity 1. So now I'm going to go to the graph, and we're going to start to put some information into the graph. For example, horizontal asymptote at y equals 0. So we can go ahead and put that horizontal asymptote in place all the way across. We have a y-intercept at 0, 1.5. We have a vertical asymptote at x equals 2. And we have two x-intercepts, one at 6 and one at negative 2. Now immediately we can see that I'm just putting those x-intercepts right on top of horizontal asymptote. That's okay. The thing about horizontal asymptote that we need to be aware of is that it is an end behavior. What that really means for us is this is what the graph will do as x approaches infinity or as x approaches negative infinity. This has no effect, and we saw this in a video, this has no effect on what happens internally to the graph. This is purely way out here to the left and way out here to the right. So we can certainly have these internals. Now let's go back and take a look at the graph, and we'll try to fill in what seems like It's the only way things can go. For example, we know that at -2, the graph has to cross through the axis. So it's either going to cross through this way, or it's going to cross through in a decreasing way. Now, how do I know which one it is? Well, I know because I've got this y-intercept that it has to reach immediately after crossing. And the only way it can reach the y-intercept at a positive 1.5 is if the graph had come from below, crosses through, and then continues to y-intercept. And look where it is. We're heading toward this vertical asymptote. So it's going to just continue the vertical asymptote. Now, how do we know that it didn't go down? Well, that's pretty easy, because if I had tried to make the graph go down, it would have to cross the axis somewhere here. But there is no x-intercept for it to do that, so that cannot be the way it goes. It's going to have to go up. In a very similar way, if we look over here on at the 6 and try to figure out what's going to happen as we move further off to the right, we have two choices. The graph could be coming from up here and heading down toward this cross through, or it could do the reverse. How do we know which one it's doing? Well, the easiest way to tell is to just take a value and plug it in, test a point. So we're going to test a point at, say, 3. And we're going to figure out where the graph is at x equals 3. So what is f of 3? And I will tell you this. I don't really care about what it is as much as is it positive or negative. So I'm going to look back here at my factored version, and I've got 1, 2, 3, 4 factors, and let's just check out the signs here. When I plug in 3, I get 3 minus 6, that is negative. I get 3 plus 2, that is positive. In the denominator, I have 3 minus 2, that is positive. And finally, when I square it and add more, I don't care what it is, but it is positive. And so what do we get from all of this? 1 negative and 3 positives, that is a negative. So f of 3 is some negative value, and that's all that I needed. That's it. Because now we know that the graph must have crossed through from below because it was coming from a negative value. So that means we go from asymptote to some point somewhere. You want the real value, you can find it, and it must cross through. We're almost done. Here's what's left. We know that the graph has horizontal asymptote and behaviors y equals 0. So the graph that looks like it's on the way up, it has to come back and begin to level out as an asymptote. Coming the other direction, it must have come again a 0 asymptote. And we're done. And this is our graph. And here we go. It's going to peel away the Desmos pre-graphed graph to see how we did. Move aside. There it is. There's the real graph of this thing. And we get all the pieces and parts that we expected. We have our vertical asymptote at 2. We have our horizontal asymptotes to the left and to the right. We have our 2 cross-through intercepts here, and there's another one we thought at 6. It is very hard to see it, but it does cross through and come back. If you zoom, you would see that. And finally, there's my 1.5 y-intercept. So there's a full example, and I think that's going to be it. You get to try a few yourself and enjoy the work.